Okay, we are on lesson 29, unit 5-7, page 320 of the pre-calculus book. We are dealing with the ambiguous case for the law of sines. The ambiguous case is for when what you are given is in the order side, side, angle. You may recall that we used the law of sines formerly when what we had was in the order of side, angle, side, or angle, angle, side. When we talk about distinct triangles, we're talking about a triangle congruent to another one, because a triangle congruent to another one is not a different triangle, it's the same triangle. The ways that we proved triangles were congruent in geometry were side, 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 angle, side, angle, side, angle, and angle, angle, side. And then we had another one which we called hypotenuse leg. Now, hypotenuse leg is for right triangles, and we're trying to deal with non-right triangles. If we were dealing with right triangles, we would use our special right triangle rules, like our 30, 60, 90 triangle rules, or our 45, 45, 90 triangle rules, or just plain old sine, cosine, tangent, or Pythagorean theorem. And we wouldn't necessarily need the law of sines or the law of cosines. And so we don't use this when we're talking about law of sines and cosines. Now on unit 5-8, we're going to deal with the law of cosines, and we're going to learn that when what we're given is in the order side, 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 or side, angle, side, we will have to begin our solving process with the law of cosines, and then we can move into the law of sines. What we learned in the lesson before this, lesson 5-6, was that if what we are given is in the order angle, side, angle, or angle, angle, side, then we will solve using the law of sines. Now, a way that we could not use to prove that true triangles were congruent was side, side, angle. We said in geometry that that does not create a distinct triangle. Therefore, we cannot conclude that two triangles are congruent by side, side, angle. It doesn't mean that there cannot be a distinct triangle. It just means that there is not necessarily one distinct triangle. Side, side, side could, or side, side, angle could produce 0 distinct triangles, 1 distinct triangle, or 2 distinct triangles, which means if we're trying to solve a triangle with what we're given in the order side, side, angle, that means there's either 0, 1, or 2 distinct solutions. Now, on page 320 of the pre-calculus book, it shows you how to determine whether there's 0, 1, or 2 distinct solutions. And we're not going to do that because it's not necessary. What we're going to do is we're going to act like there's 2 solutions to start with. And we're just going to start solving. And in the solving process, if our angles add up to more than 180 degrees, we're going to say, well, that can't be a triangle. So we're going to know pretty quickly whether there's 0, 1, or 2. Since the memory work for learning whether there's 0, 1, or 2, and the amount of work it takes to figure out if there's 0, 1, or 2, isn't much different than just solving as if there were 2 and figuring it out, then we're not going to learn that. We're just going to solve as if there were 2 and figure it out as we go. You'll see what I'm talking about in just a moment. Okay, but I'm going to read what's on page 320 just so you can get a little bit of a gist of how complicated it sounds. So, page 320, it says, case 1, if angle A is less than 90, meaning it's an acute angle, and A is less than B, then you need to check and compare A to B sine A. If angle A is less than 90 and A is less than B, and A is less than B sine A, there's no solutions. Or if angle A is less than 90 and angle A is less than B and A is equal to B sine A, then there's one solution. Or if A is less than 90 and A is less than B and A is greater than B sine A, then there's two solutions. Or if A is less than 90 and A is greater than or equal to B, then there's one solution. Or if A is greater than or equal to 90 and A is less than or equal to B, then there's no solution. Or if A is greater than or equal to 90 and A is greater than B, then there's one solution. It'd take most of us a good while just to memorize that and try to understand it. And it still takes a little while to figure it out because you still got to do B sine A. Well, by the time we do all that, we could just act like there's two solutions and solve and see if we run over 180. That's a whole lot easier. So that's what we're going to do. So we're not going to try to determine how many solutions there are before we start. We're just going to start. Okay. So we're still dealing with the law of sines. The law of sine says that sine angle A over side A is equal to sine angle B over side B is equal to sine angle C over side C. Now, what we have given is side angle. It's in the order side angle. Do you see what's locked in? This is our locked in stuff. This is going to be important in a little picture that I'm going to draw in just a minute. Okay? What is variable here? What is variable here is angle B and angle C. They have some opportunity to change so that there's either 0, 1, or 2 solutions. But what's locked in is this side and this angle. Okay? That's what's locked in this particular picture. Okay? All right. So, since we're dealing with A stuff and B stuff, we're going to begin with this part of this ratio. So we're going to say sine A, 150 degrees, sine of 150 degrees, over little a6 is equal to sine angle B, which we don't know, over little b, which is 8. And we're going to just start trying to solve for angle B. So to solve, we're going to cross multiply. We'll get 8 sine 150 degrees is equal to 6 sine B. We're going to undo multiplication by division. And so what we would have is sine angle B is equal to 8 sine. I'm going to scoot that over just a little bit. Is equal to sine 150 degrees over 6. Now, to get rid of the sine on the B, we want to do arc sine, which cancels and we get angle B is equal to. And so we need to do the arc sine of this side, and we're going to put it in parentheses like that. Okay? Now, I'm going to get another calculator to do this on. You can punch it in your graphing calculator. Make sure your calculator is on degrees. So we're going to do second sine, 8 sine 150, close that parenthesis, divide by 6, close that parenthesis, and we get 41.8 degrees. Now, we've got angle A equal, angle B equal, angle C equal. A was 150 degrees. Angle B, we just found out, was 41.8 degrees. Do you see that that's already 191.8 degrees? A triangle is only 180. You can't have a triangle like that. So that tells me that on my very first try, I ran into a problem. Therefore, there are 0 triangles that can be formed with that situation. So there's 0 solutions. Okay? Any questions on that? Okay. Now, let's stop for just a second and think before we go to the next example. I'm going to erase something here, all of this, and then I'm going to talk about what has to be true for something to be a triangle besides the fact that the sum of the angles of a triangle is 180 degrees. Now, to be a triangle, recall, if this was 5 and we had a side over here that was 3, to make a triangle, that other side, if it was 1, you could not have a triangle because 3 plus 1 is not greater than 5. To be a triangle, the sum of the smaller two has to be greater than the third. 3 plus 1 is not greater than 5, so you don't get a triangle. So to be a triangle, the sum of the smaller two sides has to be larger than the third. Now, here's the scenarios. You could have a situation like that where there's no triangle at all. Or you could have a situation like this where you had that and this was 3 and this was 4, and we know that that's Pythagorean triplets, and that would be a right angle, and we would have one distinct right triangle. And then you say, well, that's kind of cool. What if we had this side was 5, I kind of made it bigger just so you could see. But then let's say that we had a side that did something like this. Let's say we had a side that did something like this. I got to think just a second. Give me just a second to think, please. Now, there's the possibility that I could take this third side and come down here and make a triangle, right? And so what I would have is I would have this big triangle. Now notice that what I'm locked into, if I do side, angle, side, is this. You see that this is my given, my side angle. In the ambiguous case, side, angle, this is my side, and this is my side, and this is my angle. This is what's locked in. Now, in this situation, this side that's popping down through here, it could actually swing across and have popped down right here also. Which means there's 2 possible places that could actually hit. Now, I did say the side was 5, and we're going to kind of change that number because you realize if I pendulum it, it's going to change. But I could get a triangle locked in where that other side is not established, and I could get 2 independent triangles. Now, remember my given with the law of sines is this side, this angle, this side, and this angle. And so that bottom side was not a part of the given on side, angle. So my bottom side is variable. It can be short or it can be long. Well, what 2 possible triangles am I getting? Well, what I'm getting is if I take what I'm locked into, which my third side is either locked in here or it's locked in here. If I lock it in here, then what I would have is side, side, angle with that little triangle, or I would have side, side, angle with that big triangle. So the situation is that if this was potentially an angle B right here, then my angle B could actually be the angle of the bigger triangle, or my angle B could be the angle of the smaller triangle. So I've got two choices for angle B. I would also have two choices for this side down here. I could have the whole bottom, or I could have that little short piece. Now, my side-side angle parts are not variable. There's only one choice for them. That's the given. But I have some parts that I have more than one choice for. Okay? Now, it's important for us to try to see this right here. If I have two choices for this angle B, then there are this choice and that choice in yellow. If you notice, right here I have a straight angle. I'm doing it in red. A straight angle is 180 degrees. Let's just say, for instance, that this was 70 degrees. If that's 70, this would be 70 because this is an isosceles triangle, because I have that locked inside. And a triangle is 180, so 180 minus 70 would leave 110. So if that one choice was 70, the other would be 180 minus 70, which is 110. So as I begin to hunt for my missing angle, I realized that I could possibly have two choices for that missing angle. Okay? And that's how we have the possibility of having two solutions rather than one. Okay. Now, that should have been in the background of our mind as we were doing the first example. But in the first example, we ran into a dead end when we tried it the first time. So we didn't even get one distinct triangle. Now we're going to look at some examples where there's the possibility of a second. We're going to get a hit on the first one, and there's going to be the possibility of a second solution, and we're going to see how to get that from what we just talked about. Okay, so example 2. Example 2, we have that A is equal to 30 degrees. We have that little a is equal to 4, and we have that little b is equal to 8. Now, we're not sure to start with what this picture looks like, so we're going to make angle A 30 degrees, and we're just going to throw in a B and a C, and it may be all out of whack. It may be out of proportion, but we're still going to just throw in an A, B, and C and call it that. We'll call this B and little b, and we'll call this C and little c. Now, B may be acute or obtuse or right, so that may not look, that may not be drawn to scale. We have the A stuff and B stuff, so we're going to act like there's two solutions and just start solving as if there were two. And if we go over 180, we'll say, well, that didn't work. Okay? So we're going to say sine of 30 degrees over 4, sine A over A, is equal to sine of angle B, which was what we'd be looking for, over 8. Now, to solve, we're going to cross multiply. So we're going to have 8 sine 30 degrees is equal to 4 sine angle B. We're going to undo multiplication by division. And so we would have sine angle B is equal to, I'm going to leave some space, 8 sine 30 degrees over 4. Now we would need to get rid of the sine function with the arcsine function. And so we're going to need to do arcsine 8 sine 30 divide 4. So you'll punch that in the calculator as second sine, the parentheses is open, 8 sine, now the parenthesis opened again, 30, close, divide, 4, close, enter, inverse sine of 8 sine 30. I got an error because I punched it in my calculator wrong. I hit the parenthesis button and I actually didn't hit it hard enough. Divide 4, close, bear with me here, 90 degrees. And so we get that angle B is 90 degrees. Okay, let's see where we're at. We've got angle A equal 30 degrees. We've got angle B is equal to 90 degrees. Did we go over 180? No, we did not. 90 plus 30 is 120. 180 minus 120 is 60. So there was enough room for angle C. So far we have one solution, but there might be another one. Now the situation is that my second choice for angle B, because of the picture we drew a while ago, is 180 degrees minus my first choice for angle B, and 180 minus 90 is 90. My second choice for angle B is exactly the same as my first choice for angle B. That means I do not get two distinct triangles. I only have one distinct triangle because I did not get a second choice for angle B when I went 180 minus the first one. That means that there's only one solution. Now, what we know so far is we know little a, we know little b, we know angle A, angle B, and angle C. The only thing we don't know is little c. Now, if you were to use the law of sines to get angle C, you would likely get a decimal answer, and I would likely count it wrong. I wouldn't likely count it wrong, I would count it wrong. Because at this point, we should be able to redraw this triangle correctly, not that you have to every time, but this is a special right triangle. And special right triangles give us exact radical answers. And when there's the possibility of an exact radical answer, then we're not going to accept non-radical answers. Now you realize that we usually call the hypotenuse C and we call the right angle C, but this was already set up so that B was 90. So we're just going to leave that for a moment. But we know that in a 30, 60, 90 triangle, the length of the long leg, which is opposite 60, is equal to the length of the short leg times the square root of 3. And so we know that little c is equal to 4 square root 3 as an exact answer. If you use a law of sines, you would get an answer, but it would be the decimal value. And so we want you to not go to the law of sines. When we have special right triangle rules, we want you to use your special right triangle rules. And so example 1 I've shown you had 0 distinct triangles, 0 solutions. Example 2 that I've shown you has 1 distinct solution because the second choice for angle B was going to be 90 just like the first choice, so we didn't get a second distinct triangle. Now the question would arise then, is the only time you're going to get 1 the case in which the second choice for B is the first choice for B? And the answer is no. And we're going to look at another example just to answer that question of yours. Okay? So, Is the only time we get one answer when my angle turns out to be 90? The answer is no. And so we're going to go to another example to be able to see that. Okay, so example 3. Example 3, we're going to say, okay, C is 47 degrees. That's capital C. That's angle C is 47 degrees. We're going to have that A is 10. We're going to have that C is 16. All we know to do is to make C acute, 47 degrees. Opposite C is 16. Opposite A is 10. These are obviously not drawn to scale. Now, we don't know if there's 0, 1, or 2, so we're going to solve as if there's 2. And if we go over 180, we know that it can't be a triangle. So we've got the C stuff and the A stuff. So we're going to start out with sine angle C 47 over little c 16 equals sine angle A, which we don't know, over little a 10. We're going to cross multiply. We're going to get 10 sine 47 is equal to 16 sine angle A. We're going to undo multiplication by division. And so we're going to have sine angle A equal, I'm going to leave some space, 10 sine 47 over 16. We need to undo the sine with its inverse arc sine. And so we get angle A equal. And so we're going to do arc sine 10 sine 47 over 16. So second sine 10 sine 47 close divide 16 close enter 27.2 rounded 27.2 degrees. Okay, so here's what we got. ABC. Will choice 1 work? Will choice 2 work? Choice 1, we've got C is 47 degrees. It's locked in. You've only got one choice for that because that's what they gave you. For angle A, we have a 27.2 degrees. In choice 1, is there enough room for angle B? Have we gone over 180? No, we have not. So we're going to take 180 minus, angle C minus, angle A equal. And we're going to get what angle B would be. So we're going to do 180 minus 47 minus 27.2, and we get 105.8 degrees. Now, which angle did we find first? We found angle A. So to find the other choice of angle A, the one we found first, we're going to do 180 degrees minus our first choice of angle A. So if we do 180 degrees minus our first choice of angle A, 27.2, we'll have 180 minus 27.2, and we get 152.8. That means my second choice for angle A would be 152.8 degrees. Using my second choice for angle A, my second choice for angle B would be 180. Now, can you see already that using my second choice for angle A, when I put angle A with angle C, I've already got 199.8 degrees. I've already gone over 180, so there's no room for angle B. There's not even enough room for A and C in a triangle. So option 2 of angle A already puts me over 180, which means that option 2 is not an option. So I still just have one distinct triangle or one solution. What I know is angle A, angle B, angle C. I know angle A, angle B, angle C, little a, little c. What I don't know is little b, so I'm going to solve for little b. So I'm going to say sine of angle C, 47 degrees, over little c, 16, is equal to the sine of angle B, which I now know in option 1, which was the only one that worked, to be 105.8 degrees over little b, which I don't know. So I'm going to use the law of sines to find my little b. So I'm going to cross multiply. I'm going to have sine 47 degrees b is equal to 16 sine 105.8 degrees. I shouldn't have put the angle sign in there. Now, we want to get the junk off of B, and so we're going to, excuse me, I didn't mean to do that. We're going to undo multiplication by division. So we're going to divide by sine 47 degrees, divide sine 47 degrees. And so little b is equal to 16 sine 105.8 divide sine 47. So we'll punch that in. 16 sine 105.8 divide sine 47, and we get 21.1 rounded to the nearest tenth. And so we solved the triangle. And so on example 1, we went over 180 on the first try, so we said, well, there's no possible triangles. On example 2, we did not go over 180, but when we went to find our second choice by taking 90 minus the first one, our second choice was identical to our first choice, which left us with just one distinct triangle. In example 3, when we did the first one, it worked out that we had enough room for all three angles. But when we went to find our second choice by taking 180 minus the first choice, it put us over 180, and so you couldn't have a triangle with choice 2, which left you with still only one choice. In the second example, we had angle B was equal to 90 or angle B was equal to 90. We had two choices, but they were identical twins, which means we really only had one choice. In example 3, we had two choices that were not identical twins, but the second choice didn't work, which still left us with just one choice. So we ended up with one triangle in two different scenarios. Now we're going to look at example 4. And in example 4, we're going to find a situation. We're going to find a situation where there really are two triangles. So if you go over 180 degrees, there is no triangle. I forgot how I wrote it exactly. Maybe that's what I wrote. Okay, so example 4. Okay, in example 4, we're going to have angle B is equal to 36 degrees. We're going to have that little b is 19, and we're going to have that little c is equal to 30. Now, we'll try to draw this. Angle B is acute, 36 degrees. And we're not sure about A and C, so we're just going to throw them in there. So here's my B, and my little b. It doesn't really matter where you put c. I'm just going to put c right here, and little c is 30. And here's a. All right. Now, we've got the b stuff and the c stuff. I might also point out again that what we do know, regardless of whether we put a up here and c down there or vice versa, we have side, side, angle. We do have side, side, angle, the ambiguous case for the law of sines. That means that there are either 0, 2, or 1 possible solutions. Instead of taking the stuff off of page 320 of the pre-cal book and trying to figure out how many solutions there are to start with, we're just going to act like there's 2. If we run into a situation where we go over 180, we know there's not a triangle, which eliminates that option. Okay? So here we go. We're going to say, well, sine of angle B, 36 degrees, over little b, 19, is equal to sine of angle C over little c, which is 30. We cross multiply. We're going to get 30 sine 36 degrees is equal to 19 sine angle C. Now, we want to solve for angle C, so we want the junk off. So we're going to undo multiplication by division. So we're going to divide by 19. We're going to have sine angle C equal, leave some 30 sine 36 divide 19. Now I'm going to undo sine with arcsine. And find my angle C. So I'm going to do arcsine 30 sine 36 over 19. Second, sine, it's already open. 30 sine, it opened. 36, close. Divide 19, close. Enter 68.1 degrees. All right, so here's my options. A is equal to, B is equal to, C is equal to. B is equal to 36. It's locked in because it was given. Angle C is possibly 68.1. Did we go over 180? No, we did not. So we can find angle A by doing 180 minus 36 minus 68.1. 180 minus 36 minus 68.1. And we get 75.9 degrees for angle A. Now the angle we solved for was C. So 68.1 is option 1 for angle C. Option 2 for angle C is 180 degrees minus option 1. 180 minus 68.1 is 111.9. So option 2 for angle C is 111.9 degrees. Did we go over 180? No, we did not. So option 2 works also because it did not put us over 180. So in option 2, angle A is 180 minus angle B, 36, minus angle C, 111.9. And so in option 2, angle 1 is 180 minus 36 minus 111.9, which is 32.1 degrees. Now, this is important. What we are given is locked in. That means in our final result, we've only got one choice for angle B. We've only got one choice for little b. we've only got one choice for little c because that's our given. We weren't given angle A, we have two choices for that. We weren't given angle C, we have two choices for that. The other thing we were not given was little a. That means I'm also going to have two choices for little a. Okay? And so what we're going to do now is find our two choices for little a. Now we're going to use what was locked in. We're going to find little a twice. Both times we're going to use the given b stuff. Sine b 36 over little b 19 equal sine b 36 over little b 19 equal. And then we go to our a options. To find little a in option 1, we would do sine of the angle a of option 1, and that would give us little a for option 1. To find the little a for option 2, we would do the sine of the angle a in option 2, and that would produce the little a choice for 2. Okay? So we have two possible little a's because we had two possible big a's. Okay? All right. So we're going to cross multiply. We're going to get sine 36a, that's how I've been writing it, sine 36a is equal to 19 sine 75.9 We want the junk off of a, so we divide sine 36, divide sine 36. So little a for option 1 is 19 sine 17.9 divide sine 36. So we have 19 sine 75.9 close. And I hit the wrong button. 19 sine 75.9 close divide sine 36 close, and we get 31.4 rounded to the nearest tenth. So there's option 1 for little a. And now we're going to solve the other option for little a. We would have sine 36 little a is equal to 19 sine 32.1. We want the junk off of little a, so we're going to undo multiplication by division. So we're going to divide by sine 36. And so we would have that little a in option 2 is 19 sine 32.1 divide sine 36. So 19 sine 32.1 divide sine 36, and we get 17.2 rounded to the nearest tenth for option 2 for little a. And so we looked at a scenario now to where we had two possible triangles, and we found the solutions for each. Any questions on the ambiguous case for the law of sines? All right, we're going to call this part 1. We'll do the worksheet problems for part 2 of the law of sines ambiguous case.